Hello and welcome to this session on sampling. Why and how do we do it? With me, Mr. McIver, here at the London Central and Northwest Maths Hub. Why do we bother sampling? It's to find things out about a population. For instance, we might want to know about the eating habits of pupils in a particular school, or the views of some city dwellers who are considering getting a new runway at their local airport, or something more mundane like the quality of the bottles of wine coming off the end of a production line in a bottling plant. Notice that in this last case, our population isn't actually people, it's a load of bottles. Populations do not have to be human. They can be any group of objects about which we seek information. There's one other point I'd like to make about sampling before we go any further. It's a really good idea to have some idea of what it is you want to investigate before you start to plan your sample. It is possible to take a sample of an entire population. That's called a census. In the case of the school, our population is all the pupils. And I suppose in this instance, a census is possible. It could be quite time-consuming, but they're all in the one place. And it is conceivable that you could interview or measure or test every single student in that school. What about the second situation? We want to know about citizens' opinions of a new runway at the airport. Our population is all the inhabitants of this city. I guess a census is possible, but it would be very expensive. The final situation is different. Here, our population is all the bottles coming out of this factory. If we wanted to test the quality of every single bottle coming off the end of the production line, we'd have nothing left to sell. You can't do it. A census is out of the question. We are absolutely stuck with taking some kind of a sample. So, to sum up, sampling is what we do to get information about a population in a quick and affordable way. But the thing about a sample is it's a lot smaller than the population. So we have to get a few bottles or a few people to accurately represent a much, much larger group. How do we go about doing this? How do we get a representative sample? I suppose an obvious place to start would be to say, let's just make sure our samples are really, really big. And one of the biggest sampling exercises ever undertaken was carried out by the Literary Digest in 1936. This was a very popular magazine in North America. They wanted to find out who was going to be elected president of the United States in 1936. And they sent out postcards to 10 million American citizens and got 2.4 million replies. This is undoubtedly one of the biggest surveys ever carried out by any organisation, and their respondents gave them a very clear reply. Alf Landon would win by a landslide. Now, you've probably never heard of President Alf Landon, and there is a very good reason for that. He lost. This huge survey delivered the wrong answer. The alternative to making your sample really big is to make it really clever. And at the same time as the Literary Digest were carrying out their huge survey, this man here, George Gallup, an academic from Princeton University, set up a company. And his company was dedicated to using the latest statistical techniques for discovering the views of the population. And he arranged to have 50,000 interviews carried out, a 50th of the number of replies the Literary Digest got, and according to his carefully constructed research strategy, Franklin Roosevelt was going to win the US presidential election, and sure enough he did. So what was so clever about what George Gallup did? What does clever sampling look like? We've already suggested that it's based on a clearly defined hypothesis, or question. So let's make one up. And let's start off with the hypothesis: men are taller than women. There you are, that's our hypothesis. Now, as soon as we start to think about this, we probably realise that there are some short men and there are some tall women. So I suppose what we really mean is, on average, men are taller than women. Okay, now we have a revised hypothesis. No, but we've still got a slight problem here, because which men and women am I talking about? Am I talking about all the men and women in the world? That's kind of a large population. Let's just think about people in the UK. Let's change our hypothesis again to the statement, on average, UK men are taller than UK women. Okay, we have our hypothesis. Our population is men and women in the UK. And the first thing we have to do is make sure that our sample is sufficiently large. Now, when I checked, there are currently around 50 million adults in the UK. What does a sufficiently large sample of 50 million adults look like? Surprisingly enough, a sufficiently large sample can be relatively small. Here is a recent survey carried out by one of the UK's leading polling companies. I want you to look at the sentence at the top. These percentages were based on responses from 1,659 respondents. Less than 2,000 people have been surveyed to gauge the view of an entire country. And amazingly, this is statistically valid. Even for a large national population, when you're looking at a single issue, like voting intentions, 1 to 2,000 is fine, provided it's a properly constructed sample. So that's certainly going to be enough to test our men are taller than women hypothesis. So our sufficiently large sample to cover everyone in the UK is going to be 1 to 2,000. The next thing we need to do is make sure that our sample minimises bias. Let's think about how we're going to collect our data. I could hire 10 interviewers and say, go out into that street, 10 people, each interview 100 members of the population. There's our sample of 1,000. And here's a really busy street. This is actually near Piccadilly Circus in central London. You'll easily find 1,000 people to interview here, and you can just get the tape measure out, find out how tall they are. There, we've got our data. Well, there's an obvious problem with this particular approach. First of all my data comes from the one street. This may well not be representative of the entire country. Well, I can address that by simply saying, go to 10 different places. Here's my map of Britain, and I can send them off to different cities and towns around the country and say, in each of these places, I want you to measure the heights of 100 different people. Each of these regions is called a cluster, and this type of sampling, you will be unsurprised to hear, is called cluster sampling. Notice these clusters will be chosen before we start. There's nothing random about the process of selecting the geographical points at which your sampling will be done. Well, we've addressed our problem of geographical bias by clustering, but we have another problem, which always happens when you send people out into the street, and it's this. Interviewers tend to pick interviewees who look like them. If you're a young, enthusiastic data gatherer, you're probably going to look for young people that look a bit like you do to talk to. How do you address this problem of interviewer bias? Well, you very often hear people saying, use a random sample. How exactly do you go about taking a random sample at Piccadilly Circus? You can't exactly ask everyone in the street to stop while you hand them all raffle tickets and call them out. In practice, you don't get a random sample by going into the street. Random sampling requires a lot more control, and for this reason, serious social research tends not to be done by people with clipboards in the street. If you are going to carry out research this way, the best thing you can really do is what's called quota sampling. So I get my interviewers, I send them out and I say, right, I want you each to interview 50 men and 50 women. Don't worry too much about what they look like or whatever. I just want you to keep going until you get 50 of each. And I hope by having a range of interviewers and sending them to a range of geographical locations around the country, we'll get round this representativeness problem. Quota sampling is not random, but sometimes it's the best you can do. There's a slight variation on it called systematic sampling, where you, for instance, sample every 10th person that walks past. But of course, if you're doing a survey in the street, you're relying on the person you want to talk to wanting to talk to you. So you might pick the 10th person, they might not want to give you the time of day, and you're back to some kind of quota sample. We are not going to gather our sample by going into the street. Well, if you don't go out into the street, what do? You get a list of the population in which you are interested. In the case of the UK, where do we get a list of the adult population? There's actually quite a simple answer to that, a thing called the electoral roll. It's possible to get a hold of for legitimate research purposes, and this is a legally compiled list of all the people eligible to vote in the UK, all 50 million of them. If you're doing your clustered sample, I suppose you get a bunch of different electoral rolls, one for each area. Once you've done that, you assign a number to each member of that list. You then generate some random numbers, and those are the people you survey. This is how you go about getting what we call a simple random sample, if we're simply doing it for the whole country, or a clustered random sample, if we are randomising within those predetermined clusters. So is this what all the top polling companies do? Gallup, YouGov, ICM? Well, no, not exactly. We've minimised some of the biases that can emerge by clustering and randomising. However, it's perfectly possible that our random sample could randomly throw up a disproportionate number of young people, or old people, or rich people, or poor people. How do I get a sample that properly represents the overall population? Let's look back at what went wrong with the Literary Digest's famous survey. This was taking place in 1936, the depths of the Great Depression. They sent out 10 million postcards. Well, who did they send them to? They sent them to subscribers to their magazine. Just think of the sort of people who will subscribe to a highbrow literary magazine in the middle of a depression. They're probably going to be some of the better off ones. They had another list, though. They had a list of car owners, who once again tend to be the slightly better off members of the community. And they had people in the telephone book. But of course, in 1936, a lot of people didn't have telephones. The people with telephones were, yep, you've guessed it, rather well-to-do. There were a disproportionately large number of well-to-do people in this particular group. The sampling frame, these people that they were sending their postcards to, was itself biased. There was also another problem. They only got 2.4 million replies from their 10 million postcards. That means 7.6 million people did not reply. The Literary Digest kind of assumed that, well, those 7.6 million people would have said the same sort of things in the same kind of proportions as the ones who did reply. Whoops, you can't actually do that. And for this reason, this type of postcard polling doesn't happen nowadays. There is a kind of polling that happens on the internet, and you might have filled in internet surveys. Isn't that rather like postcard polling? Well, yes. And that's why it is not used for serious research. If you have ever filled in a form or some kind of survey online, it's because the person who sent it out just wants to know stuff about you. And they might then use that data to select you as part of their special sample. Or they might just use it to try and sell you stuff. But what we want to know is, what can we learn from this to put together our sample to assess this hypothesis? On average, UK men are taller than UK women. What external factors might affect male and female heights? Well, where people live might affect it, but we've already addressed that by our clustering technique. I suppose it's true that childhood diet might affect it, and might that be related to income? Just in case it is, I'm going to stratify my sample according to wealth. And I'm going to divide my sample into 3 groups: the richest third, the middle third, and the poorest third. And I'm going to make sure that I get equal numbers of data points from each of these groupings. So, to sum up, a representative sample starts with a hypothesis, or sometimes a research question. It ensures that the sample is sufficiently large. A good rule of thumb is 5 to 10% of the population you're dealing with, but make sure you've got at least 30 people, and you never really need to go above a couple of thousand. And finally, you need to think of all the different ways bias might emerge in your sample and minimize it. Clustering can address geographical biases. Randomizing can reduce interviewer or researcher bias. And stratifying can reduce bias within the sample. And you generally use all these different techniques at once, so you can have a clustered, randomized, stratified sample. Now, I'd like you to work through the questions you've been set, and I look forward to speaking to you again soon.